Hello and welcome to Crazy Math Productions. Today we're going to be looking at a general overview, a review of the Chapter 6 material. Alright, so we're going to solve and graph. We're going to show the work in the space provided. First of all, we're going to add 7 to both sides. 2x is greater than 12. We're going to divide by 2. And x is greater than 6. So now we want to graph this. Remember, we have the young man, keeps his mouth open, says unwise things. We have the old man, he knows when to keep his mouth shut because he is wise. And so now this is the young man, so he's going to keep his mouth open. And if you notice that the variables on the left and so if you look at your left hand and right hand, you put your left hand up to this, that does not fit the curvature of your hand. If you put your right hand up to it, that does match. So you're going to go to the right, shade to the right. Okay, and number 2, again, I'm going to keep, change here and switch them, commute, using commutative property of addition. We're going to subtract 4. Negative 4x is less than or equal to negative 16. Divide by 4. Whoa, what happens? We're going to have to switch the inequality symbol. So divide through, we get a positive 4. And now we're going to graph it. This is the old man, so he knows when to keep his mouth shut. This fits your right hand, so you're going to go to the right. Shaded to the right. Okay, here we're going to keep, change. First distribute. Then combine all of your like terms. Please remember key, change, or you'll get burned. Then get all your variables onto the same side. First addition or subtraction. Then multiply, divide. And I do not switch the symbol there because I did not divide by a negative. Even though I saw a negative, I did not divide by a negative, and that's a critical difference. Now we're going to graph young man, and that fits the curve of your left hand there, so it's going to go this way. Okay, and number 4. First distribute. Nope, we don't have any distributive property. Then combine all of your like terms. So that's 6x. Please remember key, change, or you get burned, and we don't have any of that. Then get all your variables onto the same side. So let's subtract 7x from both sides to get it on the same side. This is negative 1x is greater than or equal to 7. First addition or subtraction, which we don't have. Then multiply, divide, which we do. Divide by negative 1. Whoa, what happens? We're going to have to switch the inequality symbol. This is an old man, so he knows when to keep his mouth shut. This fits the curvature of your left hand, so we're going to shade to the left. And we're done with the first 4. Okay, now we're going to solve and graph each compound inequality. Now this is an AND statement. So with AND statements, we do everything at the same time. So we're going to add 2 to all of the parts. Divide by 4. And now we're going to graph. So this is an AND which here. We've got a 0 and a 3. We have young man keeps his mouth open and says unwise things, and it's an and. Remember, if you followed Crazy Math Productions, you know that's the Conan the Barbarian conjunction and statement. That's his spear. And number 6, so this will be your answer here and the graph. In number 6, we have an or statement. So I'm literally going to ignore the second path here. I'm just going to focus on the left-hand side. So we're going to divide by 3. X is greater than 4. And now I focus on the other side. Divide by -4. Whoa, what happens? Got to switch the inequality symbol because we divided by negative. So we have x is less than or equal to 2. So this is x is greater than 4, or x is less than or equal to 2. Now, we don't put this together. There's no such thing as an or which, but we do have an and which, this being an and statement. So we leave these separate. Now remember, with an or statement, you got to think of a little boat with the oars sticking out of the sides. So the oars come out of each side, so they're going away from each other. So here we have 2 and 4. Have to put them in order because of the number line has to be in the right direction. Now, x is less than or equal to 2. That's an old man at the 2. Keeps his mouth closed because he's wise. Young man at the 4. He opens his mouth and says foolish things. And then we do an or statement, so it's shaded away because it's an or statement. And that's it right there. Number 7, it's an or statement, so I'm going to completely ignore, see if I can get a better cover up here. So I'm going to completely ignore this part first and just solve the left-hand side. Remember that an and, we do everything all at the same time, whereas an or, we're going to separate the two sides and do one at a time. So now we're going to add 7 to both sides. 6x is greater than 12. We're going to divide by 6. X is greater than 2. Or, let's ignore the other side and work on this part. Subtract 1 from both sides. Negative 5x is greater than 5. Divide by negative 5. Whoa, what happens? We're going to switch that inequality symbol because we divided by negative. So now I can take that away and focus on what I need to focus. So I've solved x is greater than 2 or x is less than -1. Remember, I don't combine them together. There's no such thing as an or which. There's only an and which. So I only stick them together like this for and statements. Now, as I'm graphing this, we have -1, we have +2. This is a young man, and it's an or, so we're going to shade away from. Okay, number 8 here. This is an and statement, so we're going to do everything at the same time. We're going to subtract 4 from all 3 parts. Negative 3x is less than, that's going to be +3. Negative 5 minus 4, -9. And now we divide by -3. Whoa, what happens? We're going to have to switch all, both, I was going to say all 3. There's 2 inequality symbols here. We have to switch both of these inequality symbols. Now, I don't like them heading this direction. I don't like them going to the left. I'd rather them going to the right. So I'm going to switch the 3 and the -1, and then switch those inequality symbols. Notice that the or equal to, greater than or equal to is attached with the 3 here, so it should be less than or equal to attached to the 3 here. And then greater than -1, so it should be -1 is less than x. So I switch them in that manner. So there's my solve. And now we have -1, +3, -1. Young man opens his mouth, says foolish things. The old man knows to keep his mouth shut because he's wise. And this is an and, so we use Conan the Barbarian's mighty spear here. And there we go. Okay, solve each absolute value equation, show your work in the space provided. Again, if you follow Crazy Math Productions, you know that we look at Alice in Wonderland here. This is the mirror, and when she looks into the mirror, there's two distinct things that happen. We have the nice positive world, or we have the dark, mysterious, negative world. It splits into two parts. Now, once you've split it, don't put the absolute value symbols. Go ahead and pull those off because we've dealt with the absolute value by splitting it into two scenarios using the definition of absolute value. So now that we have two separate parts, we're going to deal with each individually. We're going to solve the left-hand side here, subtract 3, x equals 2. Now we look at the right-hand side. X equals -8. So x equals 2 or x equals -8, and there we go. Now in number 10, we've got to get the mirror by itself. We have to solve for absolute value of x minus 2, this part here, before we can do anything else. So we're going to have to get rid of the -4 by adding 4 to both sides. So the absolute value of x minus 2 equals 9. Now we're going to be able to split this into the two algebraic scenarios. Again, Alice in Wonderland, she looks through the looking glass, the mirror, if you will, and we have the positive version, or the dark, mysterious, negative world that she was looking through in the looking glass. So let's solve each part. We're going to add 2, x equals 11, or add 2, x equals -7. And those are my two scenarios. Let's look at number 11. Again, I have to get the absolute value of x plus 4 by itself. So let's do that. We're going to add 3. 3 times absolute value of x plus 4 equals 12. We're going to divide by 3. Absolute value of x plus 4 equals 4. Now I'm able to split it into the two scenarios, the happy positive world or the interesting negative world. Solve each part, x equals 0, or x equals -8. So those are my two scenarios. And finally, number 12. I have to get the absolute value of 3x minus 4 by itself, so I'm going to add 9 to both sides. -3 times the absolute value of 3x minus 4 equals +3. Divide by -3 on both sides. It's very tempting. I'll put a star here. This is very important. It's very tempting to go ahead and split this into two scenarios. There's only one problem. How in the world could the absolute value of something be negative? Now, absolute value, which is distance from 0, keep that in mind. How could the distance from 0 on a number line ever be negative? Now, if you think about the absolute value of 1, it's 1 unit away from 0 on the number line. So the absolute value of 1 is 1. -1 is also 1 unit away from 0 on the number line. So the absolute value of -1 is also +1 because it's +1 unit away from 0 on the number line. There's no way that I could possibly get a -1, so there's no solution here. So basically, when you get to this situation, if you have absolute value equals number, before you try to split it into two scenarios, you have to check, is this number a negative? If it is, there's no solution. Okay, solve each absolute value inequality and graph the solution. We're going to show our work in the space provided. Now, absolute value of 2x minus 5 is greater than 7. Alligators eating the door, so this is an OR statement. Remember, alligator eat the door, then the statement is an OR. So same deal here. We have the nice, happy, positive version, or we have the dark, mysterious, negative version. And so now we're going to add 5 to both sides. 2x is greater than 12, divide by 2, x is greater than 6, or look at the right-hand side. Remember, when it's an OR statement, you deal with each side separately. Add 5 to both sides. 2x is less than negative 2, divide by 2, and x is less than negative 1. So this is an OR statement. I'm going to go ahead, mark my graph. We have negative 1 and positive 6. Now it's a young man. He opens his mouth and says foolish things. And an oar, think of a boat with an oar. The oars go away from the boat. So you shade away just like the oars in a boat. Number 14, if the alligator eats the door, and you can think of this as a little house, and the door is right here. If the alligator, which is this right here, is eating that door, then the statement is an OR. Well, the alligator's not eating the door, so this is an AND statement. Right, AND. So now we have the nice positive world, where nothing really is different. We also have the dark negative world, and since we have that negative over there, basically what had happened is we had divided by a negative, and that means we have to switch the symbol. Okay, so we're going to keep change. We've got a negative 1x plus 3 is less than or equal to 5. Subtract 3. Negative 1x is less than or equal to 2. Divide by negative 1. And whoa, what happens? Switch the inequality symbol. Same thing here. Keep change. That's negative 1x plus 3. We're going to subtract 3 from both sides. Divide by negative 1, and whoa, what happens? We have to switch the inequality symbol again. Now, because this is an AND statement, we can flip this. We can say negative 2 is less than or equal to x, which consequently is also less than or equal to 8. We can sandwich it together. So there's the solved portion. Now we have to graph it. So I'm going to put my graph. We have negative 2. We have positive 8. It's an old man who is wise and keeps his mouth shut. And then it's and Conan the Barbarian and his mighty spear goes between the two. Okay, number 15. Now, before I even start with this, I have to solve and get the absolute value of x minus 3 by itself. So I'm going to add 2 to both sides, and we'll get 2 onto the absolute value of x minus 3 is greater than 6. Now divide by 2. Absolute value of x minus 3 is greater than 3. Now, the alligator is eating the door of the house. So this is an OR. So I'm going to go ahead and write OR. We have the two versions of the Alice in the Looking Glass. We have x minus 3 is greater than 3, or x minus 3, flip the sign, use the negative, dark negative world. Add 3 to both sides. X is greater than 6, or x is less than 0. So there's my solved part. I do not combine them simply because we're dealing with an OR. You don't OR-witch it together. You can only AND-witch it together. And now I'm going to graph. We have 0, we have 6. It's a young man for both of them. And since it's an OR, remember that the boat has the oars going away from the boat. So they go away from the boat. That's an OR statement. Okay, so 2 times the absolute value of x minus 6 minus 4 is less than 0. We're going to add 4 to both sides. 2 times the absolute value of x minus 6 is less than 4. We're going to divide by 2. Absolute value of x minus 6 is less than 2. Now we're at a position where we can think a little more clearly. We have to get that absolute value isolated. Now, alligator is not eating the door, so this is an and statement. So I'm going to write and. Remember, we have the wonderful positive version and the dark, mysterious negative version. We have to flip the symbol. And this is fairly easy to solve. We're going to add 6 to both sides. X is less than 8. And we're going to add 6 to both sides. X is greater than 4. Now, because it's an and statement, I do need to sandwich it together. So I'm going to take this x is greater than 4 and flip it so that 4 is less than x. I can also say that x is less than 8. So we get this little choo-choo train, sort of alligators going to the same direction here. 4 is less than x is less than 8. Now we need to graph it. 4, 8, young man, and since it's an and statement, we use Conan the barbarian and his mighty spear of math here. And there's my graph. Now we need to go backwards. We're going to take the graph and we're going to write the absolute value inequality. And be careful. Don't just write the inequality, write the absolute value inequality. Okay, this is an and statement, so I'm going to write the full sandwich statement. Negative 6 is less than x is less than 10. Remember, this is filled in. That's the old man. He's got the little wrinkle under his eyes. Besides that, the negative 6 is a solution, so we need to include that as or equal to. Either way, old man got the wrinkles there. So we need to have some symmetry. We need to have opposites here. Negative 6, positive 6, or positive 10, negative 10. That has not happened. So what we need to do is to find the midpoint between these two. In order to do that, let's just find the statistical average. Negative 6 plus 10 divided by 2. Add the 2 up. Negative 6 plus 10 is 4. Divided by 2 is 2. We're going to subtract that from all 3 parts. Negative 6 minus 2 is negative 8. 10 minus 2 is 8. And so now we have opposites, negative 8, positive 8. That's good. That's very good. Once we get to this point, this is an inequality, but it's not an absolute value inequality. The nice thing about setting it up where we have the opposites is that I simply put the x minus 2 in the absolute value. I take the positive version here, and then I simply have to ask, does the alligator eat the door? Well, if the alligator eats the door, it's an or statement. Well, this is an and statement. So we need to make sure that the alligator does not eat the door. So does not eat the door should go this way. And remember, old man. Okay, remember Conan the barbarian and his spear, so it goes between the two. Number 18, we're going to shade it to either side. That means that's an or statement. Remember the boat with the oars. So this is an or statement. Now, when I've got an or statement like this, I'm going to set up 2 separate. I'm going to put the x on the left-hand side to make this easier. So x, and we've got the negative 4. Now notice, this arrow, since I've put the x on the left-hand side, matches the shaded direction that we should go. So pull that straight down. X and positive 4. This arrow also matches the inequality symbol that we should have been using there. So this sets up my inequality. However, I don't have an absolute value inequality yet. I do have the opposites, symmetry there, -4, +4. So I'm going to put the x inside the absolute value. I'm going to use the positive version, and the alligator should eat the door because this is an OR. And I'm done. Okay, number 19. Graph each absolute value equation in two variables using a table of values. Now we could do it without the shortcut. We could do it with the shortcut, excuse me, but we need to use the table of values. So I'm going to go ahead and make my table of values. We start by setting x minus 1 equal to 0. Add 1 to both sides. X equals 1. That's the x coordinate of the vertex. Now plug that back in. 1 minus 1 is 0. Absolute value of 0 is 0. -2 times 0 is still 0. Plus 4 is 4. So we just plug it back in. And that gives me the y-coordinate of the vertex. The vertex is 1, 4. So from here I'm going to go up 1, up 2, down 1, down 2. And I'm simply going to plug these in. Y equals -2 onto the absolute value of -1 minus 1 plus 4. Well, that's -2. Absolute value of -2 is 2. Times -2 is -4. Plus 4 is 0. Now let's plug in a 0. Y equals -2 onto 0 minus 1 plus 4. 0 minus 1 is -1. Absolute value of that is +1. Times -2 is -2. Plus 4 is 2. Now what should happen is I should have symmetry with this vertex. These should be the same, and these should also be the same. So this should be 2 and 0. But we want to make sure that we've done our math right. If that hasn't happened, I've either plugged something in incorrectly, or I've simply not found the vertex correctly. I'd need to go back and check the vertex first. So let's plug in our 2. Y equals -2 under the absolute value of 2 minus 1, then plus 4. 2 minus 1 is 1. The absolute value of 1 is still 1. Times -2 is -2. And then -2 plus 4 is 2. So my symmetry is working out correctly. I can go ahead and assume that this will be 0 as well. Once I know that the symmetry is lining up well, then I could go ahead and finish that mirror image from the table. So 1, 4. And then let's graph the other ones in order. -1, 0. 0, 2. 2, 2. And 3, 0. Okay, number 20. Again, using a table of values, we're going to start by setting this part equal to 0 and solving. X equals -1. So my vertex, the x-coordinate is -1. We're going to plug that back in. -1 plus 1 is 0. Times anything is still 0. Minus 3 is -3. So that's my vertex. We're going to go up 1, up 2, down 1, down 2 from that x-coordinate of the vertex. And now we simply plug these in. Y equals 1/2 onto the absolute value of -3 plus 1. -3 plus 1 is -2. The absolute value of -2 is 2. Half of 2 is 1. 1 minus 3 is -2. Let's plug in -2. So -2 plus 1 is -1. The absolute value of -1 is 1. Now half of 1 is 1/2. minus 3 is negative 2 and 1/2. So now we need to plug in 0. What should happen is we should have some symmetry here. This should be negative 2 and 1/2. This should be negative 2. If that's not correct, then something has gone wrong. We need to go back and check our vertex, and then check to make sure that we've plugged these in correctly. Now let's plug in 0 and see what happens. 0 plus 1 is 1. The absolute value of 1 is 1 times 1/2 is 1/2. Again, 1/2 minus 3 is negative 2 and 1/2. The symmetry is working, so I can go ahead and assume that the rest of it will work as well. Negative 1, negative 3, 0, negative 2 and 1/2, 1, negative 2. We also go the other way. Negative 2, negative 2.5, negative 3, negative 2. And there's my graph. Determine if the given point is a solution. Write yes or no and show your work. I'm just simply going to label these x and y. I'm going to plug in negative 1 for y. Plug in 6 for x. And just work it out and see what happens. 6 divided by 3. This is a shortcut that works if the denominator is divisible easily by the product here. 6 divided by 3 is 2, times negative 2 is negative 4. Negative 4 plus 4 is 0. Now, is negative 1 greater than 0? Let's check it out on the number line just to be sure. What they're saying is negative 1 is to the right or greater than 0. Is negative 1 to the right of 0? No. So this is definitely a no. It does not work. It is not a solution because it does not make this inequality true when you plug it in. Let's look at number 22. Again, we're going to see if this is a solution. If it is a solution, when we plug this in, it'll make the inequality true. If it's not a solution, it'll make the inequality false. So let's plug in 2 times negative 3 plus 4 times 3 is less than or equal to 8. That means negative 6 plus 12 is less than or equal to 8. 6 is less than or equal to 8. Let's check that out as well. 6 would be here, 8 here. Is 6 to the left or on top of 8? Well, yes, 6 is to the left of 8 on the number line. So this is true, so we write yes. Now we want to graph each linear equality in 2 variables. Now you remember the young man and the old man. Well, there's a little bit of an extension to this. The young man does keep his mouth open, but he also doesn't have a very full beard. He hasn't quite been able to grow it out very well. Whereas the old man, he is wise, and he knows when to keep his mouth shut. But he has a full beard because he's an old man. Also, for the ones that we're able to, if the alligator eats the Y, you're going to shade to the sky. Thanks to my good friend and a colleague, John Altman. Now, if it eats the X, we're going to hit the decks. And that's going to be important as we remember where to graph these. The other way to do this is to simply find a point, plug it in, see if it is true. If it's true, shade that direction, and if it's not, shade the other. But this is a great deal simpler if you can remember it. Okay, this is in slope-intercept form. That's good. We can go ahead and graph as if it were an equals sign. So we're going to go up to the y-intercept, put a point. I'm going to put the negative in the top. You could have put it in the bottom. It doesn't matter. We're going to rise negative 1, which means going down 1, and run a positive 3. Let's do it again just for clarity and for precision of the line. Now, this is an old man. He has a full beard, so it's going to be a solid line. Also, it eats the y, so we're going to shade to the sky. What do I mean by that? We're going to shade to the sky above the line, because the alligator is eating the y, or would if he had the chance to. Now on this one, graph in two variables. Well, we don't have two variables. Well, no worry. Remember, this is the y-axis, and this is the x-axis. Now, if you were looking at the line y equals -3, which this is not, but let's just imagine for a moment, y-axis is a vertical line. Well, a y equals type line would be the opposite of that vertical line, which is a horizontal line. So let's go on the y-axis to -3. That means going down 1, 2, 3, and putting a point. A y equals type of line would be a horizontal line because it's the opposite of the axis. Y-axis, y equals. If we had an x equals, this is the x-axis, so this would be an x equals going vertically. We have a y equals type of line, which is a horizontal line, but keep in mind that this is not an equal sign. This is an inequality. Since this is a young man, it's going to be a dotted horizontal line. Now, eat the y to the sky, eat the x, hit the dex. That's for two variables. It's not going to work quite as well with the one variable inequalities. So what we need to do, it's a little different this time. We're going to pick a point, say the origin. It's just usually very easy to work with. And we're going to plug that in. Now this is x, this is y. The y is 0, so we're going to plug that in here. 0 is less than -3. Well, is that a true statement? Is 0 to the left of -3 on the number line? Well, no, 0 is to the right of -3 on the number line. So this is a false statement, which means this should not have been shaded because it doesn't make it true. So instead of shading towards this, we're going to shade away from it. Because there's only two choices. You shade towards it or you shade away from it. Since this was false, we're just going to shade away from it. On 25, the only thing that remains different is that we don't have it in slope-intercept form, and that's absolutely critical before we begin. So we're going to keep change, subtract 4x from both sides. -2y is greater than -4x minus 6. Divide by -2. Whoa, what happens? We're going to switch that inequality symbol. Negative divided by negative is a positive. Negative divided by negative, again, positive. The slope here we're going to put as a fraction. We're going to rationalize. So we're going to start at the y-intercept. We're going to go up 3. 1, 2, 3. We're going to rise 2 and run 1. We could also continue in the opposite direction if we so desire. Now at this point, we need to look. This is the young man. The young man does not have a full-grown beard, so it's going to be a dotted line. Algebraically speaking, what this means is that these points, if you pick exactly on the line, will not be true. Whereas on a solid line, if you pick the points that are right on the line, they will be true. Okay, now, eat the x. The alligator here is eating the x, so we need to hit the dex. We need to shade below the line. Okay, now we're going to use the stem and leaf plot to answer the following questions. Stem and leaf plot represents ages of people that work with Acme Computer Corporation. What's the mean age of a person working at Acme Computer Corporation? Well, what we're going to do is we're going to take each of these points and add them up. So essentially, we're going to add 23 plus 27 plus 27 plus 28 plus 28 plus 29 plus 29 plus 30 plus 33 plus 33 plus 35 plus 35 plus 37 plus 42 plus 46 plus 46 plus 46 plus 48, then plus 73 plus 77. And that's going to give me a sum of 772. Then we need to divide by the total. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the mean is 38 6/10. Now the median, we're simply going to pick the point that is directly in the middle. So directly in the middle, we're going to do the lowest and the highest. Lowest, highest, low, high, low, high, and continue this. Low, high, low, high, low, high, low, high, low, high. And we're left with 2, 33, and 35. So to take the statistical median, we're simply going to take the average, the mean, of the two middle points. 33 plus 35 is 68, divided by 2 is 34. Now, what is the mode age? What we're going to do is we're going to look for the one that happens the most. So we have, let's see, several happening twice. Only one happens 3 times, and that's the number 46. So that's the mode. Now it asks, does the mean age represent the best measure of central tendency of the ages employees of Acme Computer Corporation? Explain your reasoning. Well, I'm going to say that no, it doesn't. What happens is that the mean is going to be affected a lot by outliers. And you notice 73 and 77, that's well away from the, what you would say the cluster, most of the data points. So that's going to represent an outlier. You could think of, for example, if you looked at a small room of people, and most people, say, make around $50,000, $40,000 a year, if you put Bill Gates in the room, suddenly if you add them up and divide by the total, it'll seem like everyone's a millionaire. Well, they're not. What's happened is that that one outlier has skewed the data and has made the mean a worthless representation of central tendency. So what we're going to do is we're going to say, you know what? Does it represent the best measure of central tendency? No. The outliers have skewed the data. The median would be a better measure of central tendency. Central tendency seem just meaning mean, median, mode, range. The outliers have skewed the data. The median would be a better measure of central tendency because it's not affected by outliers. Okay. Now we're going to get some practical situations. Use the triangle given to answer the following questions. If the perimeter of the triangle can be no more than 59 feet, write an inequality that can be used to find the value of x. Now, if it's no more than 59 feet, it could be less than or equal to 59 feet, because it could be no more than. Now, inequality, we're just going to use the perimeter. It says the perimeter, which is going to go right here, is no more than, so is less than or equal to 59. To find the perimeter, we just add these three together. So 3x plus 6 plus 4 plus 7. That's my inequality that I'm going to use. Now it asks me to simply solve the inequality. Write the answer in complete sentence, or complete sentences. So 6 plus 4 is 10, plus 7 is 17. And now I'm going to subtract 17 from both sides. 3x is less than or equal to 42. Divide by 3, and x is less than or equal to 14. So it says write in a complete sentence. So I'm just going to say the value of x is less than or equal to 14. Okay, a little bit of a practical situation. You plan to stop at a Hess station after school to pick up a snack. You have $4 to spend after purchasing a flag pin for the African Children's Relief Fund. You want a 99-cent drink and some candy bars that are 39 cents each. So now we're going to write an inequality for the possible number of candy bars you can buy. Now, you've got $4 to spend, so you could spend the $4 or you could spend less than $4. It's your choice. Now, it only says we want one 99-cent drink. So since it happens just one time, we're just going to put the 99 cents. Now, we could buy multiple 39-cent candy bars. So I'm going to say 39 cents times some variable. It depends on how many you want. Solve the inequality. So we're going to subtract 99 cents from both sides. 4 minus 99 cents is going to be $3.01. We're going to divide by 39 cents. And we're going to end up with a decimal here. Rounded to the nearest hundredth, we have 7 and 72 hundredths. Now we have to write this in a complete sentence, but we also have to consider the situation. How many candy bars can you eat? Well, you're not going to eat part of a candy bar. Of course, if you do, the store owner probably is not going to be very happy with you. You're going to have to consider, can we buy 8 candy bars? Well, no. If you did the math, you would realize that it's going to be more than $4 to be able to buy your 8th candy bar. But we could buy 7. We're just going to have a little bit of change left over. So the most candy bars you can buy is 7 candy bars. Okay, that'll do it for today. Thank you so much for watching Crazy Math Productions.